Hello and welcome to this section of the Differential Equations tutor. Here we're going to switch gears a little bit because up until this point we've really talked a lot about how to solve first order differential equations using the various techniques and really getting good at the math there. But in this section we're going to switch gears a little bit and talk about how to graph solutions of differential equations. Now, it turns out that you probably have figured out by now that the more complicated a differential equation gets, the harder it's going to be to find its solution. And in some cases, if it gets too complicated, you just can't find a solution at all. We don't have a cookie cutter technique to apply and get a solution. So in those cases, for certain types of equations, you can actually learn a whole lot about the solution of the differential equation by trying to graph it rather than try to solve for the actual answer. And you might actually be thinking to yourself, well, how can you graph the differential equation if you don't know the answer? All right, well that's true. If I actually calculated the answer and got x of t, right, I could plot x of t and that would be the answer. That is the graph of the differential equation. But it turns out that for certain kinds of equations, especially first order equations, there are certain techniques that you can use to sort of get an idea for what the solution is going to look like, or at least what the solutions in general will look like, without actually solving the equation. And I know that that kind of seems hard to believe at first, but I'm going to show you exactly how to do that. Before we get to that, I'm going to choose a very easy equation that I know that we've solved before, and we're going to explore that one in detail. So let's do that right now. So let's talk about an equation that we've talked about before, or at least thought about before. Let's look at dx dt is equal to x. So this is a differential equation. Nobody would argue with that. We know that the slope of x of t, which is what we're trying to find, don't forget, what we really seek to find is x of t. X is a function of time, but the change of dx with respect to t, in other words, the slope of my answer, the slope of the graph that I'm after, is going to be equal to whatever value of x I'm at. So before we actually get to trying to look how to solve this, as far as graphing it, let's go ahead and solve it by separation of variables, because I want to point something out in the answer and I want to go through that step by step. So let's just go ahead and solve this, and not even talking about graphing, we'll just separate variables and do it. So we can move x over here and we can move dt over here, so what we'll have is 1 over x dx is equal to dt. Make sure you understand that. All we did was move the dt over here, right? And we take the x and divide, so we get 1 over x. So we can integrate both sides of this guy. So we'll have the integral of 1 over x dx is equal to dt. And I can integrate this because the integral of 1 over x is natural log of x is equal to, whoops, I'm going to integrate that side too, is integral to t plus a constant. So I've integrated the right-hand side. All right? Now, in order to get x outside from being wrapped up in this logarithm, I need to raise both sides to the power of e. So it's the natural log of x is equal to e t plus a constant. This is all inside the exponential here. So I raise both sides to the power of e. And what that does on the left is this absolute value of x just comes right out. And on the right-hand side, I can rewrite this a little bit. I'm going to write it as e to the power of c times e to the power of t. Because really these are added together, so I can split it up because this is basically equivalent. C plus t is right there. So when I multiply two exponents together, I add the exponents. I'm just doing the reverse and splitting it apart. The reason I'm going to do that is because I'm going to leave this as absolute value of x is equal to e to the power of c. This is just my constant of integration. I'm going to call that constant k. This